So today we solve 30. So 30 means that suppose B is a basis for a real vector space dimension greater than 1, which the following statement must be true. The first one is a zero vector of V is an element of B, and this is impossible because B is a basis of V. Suppose dimension V is n, that means then B is a set contains n bases, and each one and all of them are linear independent. Okay, so the first one is a zero vector, and if you have n linear independent, then zero cannot be one of them. The B has a proper subset that spans V. This is impossible because the number of B is n. If you take any proper subset, then the number of the set must be less than n. Then this set A cannot span the whole vector space. So C, B is a proper subset of a linear independent subset of V. This is also wrong, right? So linear independent subset of V contains a lot of set. Each set is linear independent. But so once you write B is an element of a linear independent subset of V, not a proper subset. Okay, so D, there is a basis for V which is disjoint from B. This is correct. Okay, suppose I times 2 into B. So this means that 2x x belongs to B, and this will create another n vectors, but it's still linear independent. So the reason is trivial. Since you have n linear independent vector, if you times 2 to each of them, then it's still linear independent because you can cancel 2. But each vector is different from the previous, and the 2b still span all the vector space. And also there's no elements in 2b. Well, it's the same as B. So if this is not correct, that means B is not linear independent. But we know that B is linear independent. So 2b. So basically 2b is not as B. 2b is disjoint union. Is disjoint from B. Okay, so let me write clearly. 2b is disjoint from B, and the reason is suppose not. Then there's a vector x. Suppose that 2x is equal to some y in B, and 2x minus y is 0. Right? Then this violate x and y be linear independent. So violate. So we prove that 2b and B there's disjoint there is no intersection. So the answer is D. And C is definitely wrong, right? It's supposed one of the vector in B is a linear combination of the other vectors. If E is correct, then B is not linear independent. So E is wrong. So the answer is D.